I am having a struggle bus moment right now. Fantastic. Okay. AC method. So exciting, people. Let's do this.
So it's just
We're solving equations now, so we'll have to use the zero product property to actually find the value of x. So it's not anything too crazy. So it's like section 3b, but it's 4b. So yeah.
So it's just the same thing we just did.
Exactly.
We're just gonna do it again.
Yeah. We're gonna really make sure you know how to factor this week. Okay. So if I have this equation, we should always have it equal to 0 when we're solving quadratics. There it already is. So we should factor this. And how did we factor these yesterday? Okay. So A times C is -60. Yeah, 4 times -15. And then B is -17. And we have to find those awesome numbers. So what multiplies to -60 adds -17? Oh gosh, see, I was going through all the options and I was not finding it. Okay. I'm like 6 and 10, 4 and 15. I was like,
Except if you, right?
yeah. -20, so it adds to -17, so multiplies to -60. Okay, so then we're going to rewrite our equation. And how would that look?
It would be 3x, it would be 4x squared minus 3,
X plus
Okay,
minus 20x.
right. So we just rewrote the first, like the middle term or whatever, with the factors, or cut it in half. What can we take out of 4x squared and 3x? And x. Can I take out a number? Nope. Nothing goes into 4 and 3 except 1.
We can take out 5.
We'll have a 4x plus 3 left over, right? And then -5. Then what's left over?
4x plus.
Okay.
So you have 4x plus 3 and x minus 1.
Yeah. And this is still equal to 0. I should have been writing that into this whole thing.
Right. Just as long as you put it up there, right?
Right. So now since it's equal to 0, we can set each part equal to 0. So 4x plus 3 equals 0, and x minus 5 equals 0. Then I could solve each of those separately.
So 4x equals -3, so -3/4.
Yep.
And x equals 5.
So these are my two possible answers. Lovely. See, that's not too bad. Or I should have been timing this. You should let me know when I run out of 15 minutes.
Put that down on the board.
Yeah, because I think I'm going to go over. So I'll have to stop and then restart it.
Okay.
Okay. Whoa, whoa, whoa.
Biscuit.
You
I saw
scare
that.
me every time you say that. I just think you're just gonna slip up.
That's a big problem down there.
It's not that bad.
What's bad?
It isn't.
Can you scroll down a little bit? You have
I just need that one.
Okay.
You have to move everything over.
There we go.
Alright,
I'm good.
okay, so we're gonna add 14y
Yahtzee.
and 48.
Right? We want it equal to 0, so we're moving everything over. So that's gone, that's gone, equal to 0. And
You are left with 3y squared plus 36y plus 108.
okay. Yeah. So these numbers look like very large to me. Can we divide something out of all of these?
You can find 3.
Yeah, does 3 go to 108?
Yes.
Yeah.
Because all three numbers add to a number that's divisible by 3.
Oh. Yeah.
Yeah, and I just
See, I forgot about that rule. I was like, where you go?
I use that all the time.
Yeah.
That's like
is
something
a
I
nice
learned that
rule.
I use.
it's like something that you.
So the question is 108
You
divided
can divide it by 6 too, but you can't
3 by
divide 3
6.
by 6.
Okay. I don't know what it is.
Yeah, I was getting there.
And now you do your ANC, right?
1 minus 36. Right?
What?
Huh?
Oh, no, it's the 36. I was thinking
We
it was,
do.
I was trying to multiply, but I subtract.
Oh.
Now we do our AC, right?
Yeah.
Okay. You got 36, right? Okay, we're gonna
Oh, yeah, sorry. Yeah. So what are my factors?
Sorry.
What are my factors? 12 plus 36 times 12.
6 and 6.
6 and 6. On this one, do I have to do the full AC method? No, my A value is 1, so I could just write it in the factor form. Does anybody remember how that would look?
In factor form?
Mhm.
It's
5 plus 6, 1 minus 6.
yeah.
So since my factors are both positive 6, they both have to be y plus 6, y plus 6. Okay? So yeah, that's only when the A value is 1 that you can do straight to factor form and not do the full method there. I could write it as y plus 6 to the second power if I wanted to. This was a perfect square trinomial, I could use that shortcut. Recommend 36 is perfect square. Okay. I still want to solve this for y though.
Right, so you have y plus 6 equals 0, so y equals negative 6 on both sides.
So technically, if I wanted to get rid of square, it's square root. But yeah, it's y equals negative 6. And we could always check these by plugging them back in. So nobody ever wants to do that.
Yeah.
Yeah. Okay. And then we have this one and a story called the movie. So we did problems like this in 4-3D. We want to factor the right side and use it to find 0, so the x-intercepts basically this problem. Hello, problems. Okay, so let's just factor this right side.
AC.
So we
Negative 2. Negative 20.
okay. Negative 21. I could rewrite this lovely thing with my factors. Yeah. I have an A value, so I have to write it in 4 terms. I can't go straight to factored form. And we know we cut it in half. Yep. What can I take out of the first 2?
4x.
And what's left over?
X. Or just x. It's 5.
Okay. And what can I take out of the last 2 terms? 1.
So you really don't even need to write that.
I like to write it down so that way I can see how it factors.
X minus 5 and 4x minus 1.
Yeah.
Oh, yeah.
Or it's plus 1, right? Did I take out
Oh,
the
yeah,
last
sorry
one?
about that, yeah.
Okay, this is still
Oh.
equal.
Does it matter which order you put it in?
Nope. Okay, so this is in intercept form, which is our goal. And then since it's in intercept form, I can find the x-intercepts of the graph using zero product property, set each factor equal to 0. And so
Nice.
So 4x plus 1 equals 0. What x value do I get? Can I solve that?
Minus 1, 4x, negative 4.
I don't like that.
Negative 1/4.
The fraction, yeah. And the other one, add 5. So those are my x-intercepts. So if I was actually graphing this parabola, this would be the 2 points on the x-axis to graph it.
Genuine question. Where will this be
The graph parabolas, please.
applied? Where? What occupation would I?
Oh, many things.
No, okay, no,
No, give me
listen.
3.
What?
Give me 3.
No, I don't want to.
Because you know.
You're an architect?
Look at that.
Parabolas.
Wait, could you go back up to
Oh,
the
wait,
front
there's
here?
a thing that's supposed to go either end.
Yeah.
Oh.
Okay, I'm good, sorry about that.
These parabolas aren't
Parabolas
even-
aren't even on here.
There's quadratics on there.
Oh, yeah.
Well, I don't know. I'm gonna stop it and restart it because I'm pretty sure I'm gonna run out of time. Yep.